So the last thing we did was alternating series test, and we did, it is test number 8 of all the exact tests that we have so far. And the alternating series test, basically you have, it alternates in terms, so you will see a -1 to the n, +1 or n -1 or n, something like that. Also, the tests that you can use for the alternating series test is as follows. You check to see if the term that is not the -1 to the n +1 is positive. Then you check that it is a decreasing sequence. That means UN is always bigger than or equal to UN +1 after a certain point. And then you look to see if the limit is 0. So we did one example. We did an easy one. So here was one where UN was just 1/n. So I want to do 2 more. Okay, so in order to do 2 more, that what I want to do is this one. So that was example 1. So here is example 2. All right, so let's move this out the way so I can. Okay, so example 2 is the sum n equals 1 to infinity of -1 to the n times n squared plus 4 over n squared plus 5. Okay, so as I look at this, I can see that my UN is the n squared plus 4 part over the n squared plus 5. And as I look at this, I'm not even going to bother to do the test on the first 2 parts of the test. Well, I'll do the first part, U positive. So I know UN is greater than 0. So I know that UN is positive, so that's not a problem. The B is hard. That's always the hard part. So B is the part that, if you can, I save for last. C is easy. If I look at the limit as n approaches infinity of n squared of UN, UN, not U to the n, I'm sorry. UN, that's the limit as n approaches infinity of -1 to the n. Nope, kill off that. I just want n squared plus 4 over n squared plus 5. Can anybody tell me what that limit is just by looking at it? Anybody that's good with being able to determine things very quickly? Anybody tell me what that is? Okay, all right. Well, I can tell you that limit is 1. And the reason why I can tell you that limit is 1 is because as n gets big, I don't care about that plus 4 and plus 5. So it looks like n squared over n squared, which is 1. But the way we really have to do that is as n goes to infinity, we get infinity over infinity. So we can use L'Hopital's rule, which is on exam 1. For those of you who want to retake exam 1, L'Hopital's rule is on there. There's an easy one and there's a difficult one. So this is the limit as n approaches infinity. Take the derivative, I get 2n. Take the derivative, I get 2n. So that's the limit as n approaches infinity of 1, which is just 1. So this is not equal to 0. So we cannot conclude that this series converges. because it fails the alternating series test. And I do need to check up something, because if it fails the alternating series test, I need to see whether that means it doesn't converge. Okay, so I need to double check to see whether or not we have to say that it is divergent or we just don't know. For some reason, I can't remember right now, so I'll double check that. Okay, number 3 is another type of problem. So if I look at the limit, the sum n equals 1 to infinity of 10 n over n squared plus 1. Okay, so the question is, first, oh, I forgot my minus 1 to the n. (10n over n squared plus 1). Okay, so when I look at this, I get un is 10n over n squared plus 1. So if I put anything above 1 in there, I can clearly see that un is always positive. And C, I can see that the limit as n approaches infinity of un, which is the limit as n approaches infinity of 10n over n squared plus 1, that is infinity over infinity. So let's use L'Hopital's rule. And so we get the limit as n approaches infinity of 10 over 2n. And that's just 5 times the limit as n approaches infinity of 1 over n. And I know that limit is 0. So the first one checks, yay, and the last one checks, yay. So now let's go back and do B. Okay. So B says un plus 1, un has to be bigger than or equal to un plus 1. So it has to be a decreasing. The terms have to be decreasing. And that means after some number, they don't have to be decreasing all the way, but after some n, they have to be decreasing. So one easy way to determine whether it's decreasing is to look at the function. So if un is 10 n over n squared plus 1, let's make a function f of x that is 10x over x squared plus 1. And if the derivative is negative, then the function is decreasing, which means the sequence of un will be decreasing. Okay, so let's look at f prime. All right, so that's 10. Let's move the 10 out. Not gonna fool with that. Okay, so that's the bottom, which is x squared plus 1, times the derivative of the top, which is 1, minus the top, which is x, times the derivative of the bottom, which is 2x, all over x squared plus 1 quantity squared. So I get 10, and then I have x squared, then I have minus 2x squared. Oh, somewhere is an x missing. This should have been 2x. So I have x squared plus 1 minus 2x squared over x squared plus 1 squared. Okay, still taking the derivative here. So this is 10, and then I'm going to get 1 minus x squared over x squared plus 1 squared. So that's the derivative, okay? So clearly, if x is bigger than 1, then f prime of x is negative. So that means that un equal to 10 over 10n over n squared plus 1 is decreasing for n greater than 1. So therefore, B checks. Okay, so A, B, and C all check now. So therefore, I can say by the alternating series test, the summation n equal 1 to infinity of minus 1 to the n plus 1 times 10n over n squared plus 1 converges. I don't know what it converges to, but I know it converges. Okay, so now I want to define two things. All right, so these are two other tests that we do. And so after you do the alternating series test, you need to follow it up with these two tests. So that was number 8. So number 9 is the test for absolute convergence. Okay. So the test for absolute convergence says a series summation an converges absolutely if the corresponding series of absolute values converges. Okay, in other words, if summation of the absolute value of an converges, then the summation of an converges absolutely. Okay. All righty, so let's look at these two series. Number 1 is the summation n equals 1 to infinity of minus 1 to the n over n squared. Okay, now I can actually do the alternating series test on this series. Okay, but I'm going to use the test of absolute convergence because if it converges, absolutely, then it's said to converge. Okay, so any series that converges absolutely says it converges. Okay, so if this converges absolutely, I'm right, I wrote that wrong, that's why. Then you can just say that converges, the series converges. That's what it's supposed to be. Okay, so one, I could do the alternating series test on this. And it will show this series converges. So if you do the alternating series test on that, I think you should practice that. You can show that that converges. But B, let's look at the sum n equals 1 to infinity of the absolute value of minus 1 to the n over n squared. So this is the sum n equals 1 to infinity of 1 over n squared. Now, does this series converge or diverge? Can anybody tell me quickly whether this series converges or diverges? I'm looking at rooms that don't have no people. I'm looking at ceilings. I'm looking at beds.
Convergence.
I'm looking at rooms with no people. And I think a lot of times students feel like you can't learn online, but that's because you have so many distractions. You walk away from the computer. Okay, does this series converge? Come on, this was an easy one. Bam, bam, bam. This is an easy one. On the test, this one should take you all of 20 seconds. Who said it converges? Okay, I got some people in the chat. Okay, I have 2 people that say it converges. Why does it converge? Tell me the test you used. What test did you use to arrive at the fact that it converges? Yes, it does converge.
Can I say something?
Yes.
I say that it converges because the n squared is bigger, so over time, is decreasing, so it will converge.
Okay, so actually that is a good theory, but that actually does not work because remember summation 1 over n does not converge, but summation 1 over n squared does. What's the difference? Summation 1 over n cubed converges. Summation of squared 1 over the square root of n does not. Okay, guys, this is a P series. This converges by P series. P equals 2. Okay, so since the summation of the absolute value of minus 1 to the n over n squared equal to the summation n equals 1 to infinity of 1 over n squared converges, then that implies that the summation n equals 1 to infinity of minus 1 to the n over n squared converges absolutely. And since it converges absolutely, that also means the summation n equals 1 to infinity of minus 1 to the n over n squared converges. So if it converges absolutely, it converges. Okay, so that example, nice, easy example, I could have used the alternating series test and show that it converges. But when I look at the absolute value of the test, absolute value, I see it converges absolutely. Okay, so I need to be able to say, when I use the alternating series test and I find out whether or not it converges, I need to check to see if it converges absolutely. Okay, number 2. Summation n equals 1 to infinity of minus 1 to the n over n. Okay, so A, if I use the alternating series test, it will tell me that the summation n equals 1 to infinity of minus 1 to the n over n does converge. Okay, so does it converge absolutely? All right, well, B, let's look at the sum. N equals 1 to infinity of the absolute value of minus 1 to the n over n is equal to the sum n equals 1 to infinity of 1 over n. That's the harmonic series. And the harmonic series is divergent. So the summation n equals 1 to infinity of minus 1 to the n over n converges, but it does not converge absolutely. Okay. So here's here's test number 10. And this is the test for conditional convergence. All right. Okay, so the test for conditional convergence. A series.
I'm not sure I understand.
Oh gosh, the phone thinks I'm talking to it. A series that is convergent but is not absolutely convergent is conditionally convergent. All right. So here's two series. One, summation n equals 1 to infinity of -1 to the n over n cubed over n cubed plus 5. Okay, so the question is, does this series converge or not? So let's first do the alternating series test. All right, so we can do the alternating series test. And so A, my UN is 1 over n cubed plus 5. Okay, so let's see. So we have A, UN equal to 1 over n cubed plus 5 is definitely positive. C, the limit as n approaches infinity of UN equal to the limit as n approaches infinity of 1 over n cubed plus 5 is clearly 0 because n cubed blows up. B, we must now show that UN is bigger than UN plus 1. Well, that's actually not too hard. Okay. N cubed is certainly smaller than n cubed plus 5. So that means that UN equal to 1 over n cubed plus 5 okay, that's not what I was trying to show. Not what I was trying to show. N cubed is certainly less than n plus 1 cubed. So n cubed plus 5 is less than n plus 1 cubed plus 5. That's what I was trying to show. So therefore UN, which is 1 over n cubed plus 5, is certainly less than 1 over n plus 1 cubed plus 5. And that is equal to U, wait a minute, Dawn. This is greater. Thank you. UN plus 1. So we showed it. Okay. So by the alternating series test, the sum n equals 1 to infinity of -1 to the n over n cubed plus 5 converges absolutely. I mean, converges. Okay, so now we need to check for absolute or conditional convergence. It's only going to have one. Okay, so to check for absolute convergence, we need to look at the summation n equals 1 to infinity of the absolute value of -1 to the n over n cubed plus 5. And that is the sum n equals 1 to infinity of 1 over n cubed plus 5. So now the question is, does this series converge? And I say it does. I can prove it converges either by the limit comparison test or by the direct comparison test. So say we use the limit comparison test. So to use the limit comparison test, I'm going to let an be 1 over n cubed plus 5. And I'm going to let bn be 1 over n cubed. Okay. So I take the limit as n approaches infinity of an over bn. So that's the limit as n approaches infinity. An over bn is going to be n cubed over n cubed plus 5. That gives me infinity over infinity. So I'm going to use L'Hopital's rule. And I get the limit as n approaches infinity of 3n squared over 3n squared. But that's just the limit as n approaches infinity of 1, which equals 1. Okay, so by the limit comparison test, they both converge or diverge. But the summation n equals 1 to infinity, 1 over n cubed, what does it do? Does it converge or diverge?
Converge.
Good, this converges by P series. P is equal to 3. All right, so that converges. So that then implies that the summation n equals, I want blue, I want blue, I want blue, I want blue. That the summation n equals 1 to infinity of 1 over n cubed plus 5 converges by the limit comparison test. But then that implies that the summation n equals 1 to infinity of minus 1 to the n over n cubed plus 5 converges absolutely by the test for absolute convergence. But then that implies that's all we needed. So this series, look, it took a minute though, guys. We had to start with, we started with the alternating series test, showed it converged, and then went on to do the absolute convergence test and showed it converged absolutely. If it did not, then we would have had to say that it converged conditionally.